Hey everybody! In today's lesson, we're going to learn how to classify real numbers. So in the last lesson, we talked a little bit about natural numbers. Remember, those are the numbers that we count with. Whole numbers are all of those numbers plus 0. We talked about integers. Remember, I reminded you that integers are the whole numbers plus their opposites. And that just because a number has a negative sign in front of it does not make it an integer, okay? And then there's a new word, or new vocab here, simplify, which really just means if we're not talking about a fraction, we're talking about making something less complicated, easier, clearer. In other words, actually do the math. Find the solution, the answer, okay? All right, so we're going to classify numbers. Now, what you see right here, this is a diagram of the set of real numbers. So in the last lesson, we talked about what is a rational number and what is an irrational number. You cannot be both rational and irrational. You are one or the other. You cannot be both of those. You're either one or the other, okay? And so there's a separation here between rational and irrational. Rational numbers, however, though, have different subsets, and we have a Venn diagram here. So we've talked about natural, whole, integers, and rational. So we said natural numbers are all those numbers that we count with when you first learned how to count. So 1, 2, 3, and on. Then those whole numbers are all those numbers we count with plus 0. Integers are any of your whole numbers plus their opposites. And then rational numbers are just numbers that can be written as a fraction. Okay, so we're going to classify, we're looking at number 1, we're going to classify or put each of those values into the section of the Venn diagram that it belongs. So the first thing I need to do, though, is look at my first number, negative 10 over 2. Well, negative 10 over 2 can be simplified to negative 5, right? So where would we place negative 5? So the easiest thing, is it irrational? No. Okay, so it's a rational number. Is it an integer? Is negative 5 an integer? Yes, it is an integer. Is it a whole number? Is it a natural number? No. But it is an integer, so I'm going to put it right here in this section. Somewhere in the integer section. There's negative 5. I'm going to put a line through it so I don't look at it again. The next one I have to classify is the square root of 36. Well, 36 we know is a perfect square, so the square root of 36 is 6. And unless you see the negative outside that radical sign, we're just going to do the positive root here. So the square root, the positive square root of 36 is 6. Is that an irrational number? No. Is it rational? Yes. Is 6 an integer? Yes, it is. Is 6 a whole number? Yes. Is 6 a natural number? Meaning, do you count with it? Of course you do. So it's going to go right here in this section, the natural numbers section. That's where it's going to land. All the natural numbers are whole numbers, integers, and rational. Okay, so that goes there. The next one I have is 0/8. Well, 0/8 is just 0. So really I'm classifying 0. Is 0 irrational? No. So that means it must be rational. Okay, is 0 an integer? Yes. Is 0 a whole number? Yes. Is 0 a natural number? Do you count with 0? No. It is so whole numbers where I left off. So it's going to go right here in the whole numbers section. Okay? Let's do the next number, 7. Is 7 irrational? Nope. Then it must be rational. So it's here. Is 7 an integer? Yes. Is it a whole number? Yes. Is it natural? Yes, because you count with it. So the 7 goes there. Okay, now we're on the square root of 140. Well, 140 is not a perfect square. So is the square root of 140 a rational number? Irrational number? Yes, it is irrational. So it's going to go over here, and I don't have to ask any more questions. Okay, next. Now we're looking at 4/9. Is 4/9 irrational? No, it's written as a fraction, so it's not irrational. So it goes over here in the rational section. Is 4/9 an integer? No. So we can actually stop right there. We can't go any further. If it's not an integer, then it's not a whole number or a natural. It's just rational. So it's going to go in the rational section. Okay, let's do the next one. The square root of 4. Well, 4 is a perfect square, right? So, and its square root is 2. Okay, so is that irrational? No. Is the square root of 4, aka 2, is it rational? It must be. If it's not irrational, then it's rational. Is it an integer? Yes. Is it a whole number? Yes. Is it a natural number? Is it a number you'd count with? Yes. So the square root of 4 needs to go in this section. And you know what? I just realized I need, instead of 6, I should have written the square root of 36, shouldn't I have? And instead of 0, I should have written 0/8. And instead of -5, I should have written -10/2. Let me change those. Change those really quickly, just like you saw me do. Sorry about that. Okay, my next one is -8. Is -8 irrational? Nope. So it's definitely rational. So it's going to go on this side somewhere. Is it an integer? Yes. Is it a whole number? No. So it's going to go in this integer section. So I'm going to write -8 in the integer section. Okay? Next, the square root of 8. Well, 8 wasn't a perfect square, so square root of 8 is irrational. And the last one is -2.89. So is that irrational? No. It is a terminating decimal. Terminating decimals can't go here. So we know it's going to be on the rational side. Is -2.89 an integer? No. It has a negative sign, but to be an integer, you don't have any decimal attached to you. Okay? So it is not an integer, which means it's not whole and it can't be natural. It is just rational. So -2.89 would go here. Okay. Now it's going to be your turn. So I want you to do problems 2 and 3. You're going to actually finish this off. Make sure that's... Yeah. I want you to pause the video and finish the worksheet. So go ahead and do problems 2 through 13. Then we'll come back and check. All right, everybody, welcome back. So now you want to check over your answers. So you can see problems 2 and 3. I just want to point out real quick, remember that pi is your most famous irrational number. It always, if it's the pi symbol, it always falls underneath irrational. All right, so I'll give you a couple seconds, pause the video, and make the necessary changes. Okay, let's go to the next page. Let's see, 4 and 5. Okay. And then here are problems 6 and 7. And problems 8 and 9. And let's see, there's 10 and 11. And then 12 and 13. Okay, guys, hopefully you did well with today's lesson. If you have questions or need clarification on something, don't hesitate to contact me so I can help you. Go ahead and turn this in, and then you're ready to work on today's independent practice. Good luck.